Tuples in Python are immutable sequences of arbitrary objects. Once created, the objects within them cannot be replaced or removed, and new elements cannot be added. Tuples have a similar literal syntax to lists, except that they are delimited by parentheses rather than square brackets. Here's a literal tuple containing a string, a float, and an integer. We can access the elements of a tuple by a zero-based index using square brackets. And we can determine the number of elements in the tuple using the built-in len function. We can iterate over tuples using the for loop, and we can concatenate tuples using the plus operator. Tuples can be repeated using the multiplication operator. Since tuples can contain any object, it's perfectly possible to have nested tuples. We use repeated application of the indexing operator to get to the inner elements. Sometimes a single element tuple is required. To write this, we can't just use a simple number in parentheses. This is because Python parses that as an integer enclosed in the precedence controlling parentheses of a math expression. To create a single element tuple, we make use of the trailing comma separator, which we're allowed to use when specifying literal tuples, lists, and dictionaries. A single element with a trailing comma is passed as a single element tuple. This leaves us with the problem of how to specify an empty tuple. In actuality, the answer is simple. We just use empty parentheses. In many cases, the parentheses of literal tuples may be omitted. This feature is often used when returning multiple values from a function. Here we make a function to return the minimum and maximum values of a series, the hard work being done by the two built-in functions min and max. Returning multiple values as a tuple is often used in conjunction with a wonderful feature of Python called tuple unpacking. Tuple unpacking is a destructuring operation which allows us to unpack data structures into named references. For example, we can assign the result of our min-max function to two new references like this. Tuple unpacking works with arbitrarily nested tuples, although not with other data structures. This in turn leads to the beautiful Python idiom for swapping two or more variables. Should you need to create a tuple from an existing collection object, such as a list, you can use the tuple constructor, here also shown for strings. Finally, as with most collection types in Python, we can test for containment using the in operator, or non-membership with the not in operator. While that just about wraps up our look at tuple, let's move on to the next collection type.